So hopefully we all know that 2.5 times 2 equals 5, right? Now what about 2.5 plus 2? What if I were to tell you that that can sometimes equal 5 as well? Now doesn't that sound weird? Well, welcome to the world of significant figures. Hello and welcome back to Class Physics, where I try to talk as quickly as possible and stutter as little as possible. In hope of achieving those two goals, I'm going to be calling significant figures sig figs for the rest of this video. I have to give the general disclaimer once again that I'm definitely not an expert in physics. I'm just someone who thinks that it's really interesting. So let me introduce myself again. My name is Maggie, I'm 15, my hair is weird because I slept on it while it was wet. Pro tip, don't do that. And more importantly, I decided to cover sig figs today because I was looking at one-dimensional movement and I noticed that a lot of the measurements have to be rounded to a specific number of sig figs. So, what exactly are sig figs? How do we use them and why do we use them? Well, to get into that, let me present this scenario for you guys. So let's imagine that you're having a party with 3 of your friends. Bill says that he'll be at your house sometime in the afternoon. Molly says that she'll be there around 3. And Jill says that she'll be there at 3 p.m. on the dot. So when should you be expecting these 3 friends to arrive? Well, their answers definitely varied in terms of specificity, right? Jill's 3 p.m. on the dot is very, very specific, while Bill's sometime in the afternoon isn't really specific, or is it really even helpful? Just like your friends' answers varied in degrees of specificity, measurements made with different numbers of sig figs vary in terms of precision, because sig figs are the digits in a measurement that determine how accurate that measurement is, and we can use them to determine where to round off a calculation based on those measurements. So why is it that important to know where to round off calculations? Well, for most of us, it probably won't be that useful. If you're just trying that recipe someone gave you and you want to have all the ingredients, you're probably not going to be counting sig figs in the cups of flour that you put in. Or if you're trying to lose or gain weight and you want to figure out how much weight to lose or gain, you probably won't be counting sig figs when you find the difference between your current weight and your preferred weight. So why is it that important for us to know what sig figs are and how to use them? We need to use sig figs for calculations that have to be very accurate and precise. Now that we know why we use sig figs, how exactly do we use them? Well, there are a few basic rules on how to use sig figs. Non-zero numbers, zeros between non-zero numbers, and trailing zeros where there is a decimal are always significant, whereas leading zeros and trailing zeros where there is no decimal are never significant. Sound like a lot of rules? Well, I have this cheat sheet right here because I can never remember how to say them perfectly. Congratulations to you if you got that on the go, but unfortunately I didn't, and I hope that some of you are like me. So, let's think about the Atlantic and Pacific Ocean. If you're not seeing how they work as a mnemonic device, let's think about where they are in relation to the US. The Atlantic is in the east, or on the right, whereas the Pacific is in the west, or on the left. Using this rule, we first check to see if a number has a decimal or not. If the decimal is present, then we start in the Pacific, or on the left, and we don't count any sig figs until we reach the first non-zero digit. Once we get to it, we count it and all the digits that follow it until we reach the other side of the number. We do the same thing but in reverse if there is no decimal or if the decimal is absent. We start in the Atlantic or in the east or on the right, and we don't start counting sig figs until we reach our first non-zero digit. Then we count that digit and all the digits that follow it. Let's take a good look at our first example here, 7,000. There is no decimal, right? So we start in the Atlantic or on the right. We don't start counting sig figs until we reach our first non-zero digit, which just happens to be the 7, and we count all the digits that follow it to the left. Well, there aren't any there, right? So it's just the 7. So this number has 1 sig fig. Now what if we added a decimal to this number? It's still 7,000, right? Does it still have the same number of sig figs? Well, let's check. The decimal is present, so we start in the Pacific or on the left, and we don't start counting sig figs until we reach our first non-zero digit from the left, which just happens to be our first digit, 7000. So all of these are sig figs. So when we write 7,000 this way, it has actually 4 sig figs. Now, why would anyone bother to add a decimal when there's nothing following the decimal? Well, it's to show that whatever instrument was used to measure this 7,000 was precise enough to measure the ones, tens, and hundreds place. It just didn't find anything there. This makes 7,000 as it's written right now a lot more precise than 7,000 the way it was written before. The way it was written before, it was useful too, but we only knew what was in the thousands place. We didn't know anything about the hundreds, tens, or ones place. Confusing, right? Now let's try a different example. It seems like I really like sevens today, right? Well, it is a lucky number. So let's try to count the sig figs in this number. As we can obviously see, the decimal is present, so we start in the Pacific, or on the left. We don't start counting sig figs until we reach our first non-zero digit, which is this 7 right here. Then we count all the digits that follow it to the right. So this number, as it's written, has 4 sig figs. Now, why did we count this 0 right here, but not this 0? Well, if you guys will remember from our list of rules, all trailing zeros where there is a decimal are significant, while leading zeros are never significant. I hope that this will help you guys to see that the Atlantic Pacific rule is really just the same as a set of rules that we looked over earlier. They're just different ways to look at the same thing. Whichever way you choose to use, I hope that this video helped you guys to learn or relearn sig figs. I hope that you like this video, and if you want to see more like it, like and subscribe, and tell me what other ways you use to find sig figs in the comments. Bye!